Now we are discussing about atmospheric pressure and gas pressure. At sea level, the atmospheric pressure is 1.013 into 10 to the power 5 pascals. We also call it as a 1 atmosphere. The Italian scientist Evangelista Torricelli, he was the first person to demonstrate a method for measuring the atmospheric pressure. He lived from 1608 to 1647, very short span, 39 years. So in his experiment, he used the mercury-based method for measuring the pressure and pressure differences. That's what we will study now. This time we are taking a long glass tube. You can see here, this is the long glass tube. The one side of this glass tube is closed and the second side is kept open. So this is in the mercury. This is not a normal liquid. And you see here, whatever the gap we are observing here above the point A, there is no air. We are having only mercury vapor. Practically, the pressure of this mercury vapor at this point is 0. So the pressure at the point A is 0. Whereas the pressure at the point B is, we know it is rho G H. Because this point is having the depth of H from the point A, so its pressure is rho Gh. Whereas the pressure at the point C is atmospheric pressure, it is PA. This is called as the mercury barometer. Because we are using here mercury, this is called as mercury barometer. So in this experiment, when the height is equal to 76 centimeters, then the pressure at the point B, it will become 1 atmospheric pressure. The general way of measuring pressure in the centimeter or millimeter of mercury, that is, we generally, sometimes we take the term 1 millimeter of mercury. We also call it as 1 millimeter of mercury. It is also called as torricelli. So 1 torricelli equal to 133 pascals. Where we use this? In generally, the millimeter of mercury and tar we use in the medicine and physiology, because we want to know the small variations to the large variations there. So that's why it is very much useful. And in meteorology, a common unit we use bar and millibar. 1 bar is equal to 10 to the power 5 pascals. We also have one more instrument called as open tube manometer. We discussed just now. We are using the mercury in the measuring of the expressing the pressure, millimeter of mercury, millimeter of hydrogen, like that. So here, what liquid we have to choose? Only mercury we have to choose. If we want to measure the pressure differences which are very less, then we can even use the oil. If we want to measure the pressure differences which are very high, then we have to choose the mercury. Here we have a U-tube, which is consisting the one side, here the pressure is point P, and the second side, it is the pressure is PA. Now we want to measure the difference between P and PA. The pressure at P, so the pressure is same at A, so this is P. Because A and B are at same height, the pressure at B is P. Now the difference in the pressure is PA minus P, or we can also say P minus PA, because compared to PA, the pressure of the P will be higher. So the difference in the pressure is P minus PA. This is how we can calculate the pressure difference from the height H. And why we are always taking mercury or oil, any liquid, for measuring this pressure difference? Because liquid is incompressible. Liquid's density does not vary with the variation of the pressure or temperature. That's why we use the mercury for the measurement of the temperature in the medicine. And similarly, when we take the gaseous substance, its density changes with the temperature and pressure. So that's why it is compressible. We can compress the gas, but we cannot compress the liquid. So it is incompressible.